Alright, well there's what we've gotten so far, so if you're watching the video, catch up.
Okay, so every exponent has a base and it has a power. If I have a to the n, what's the base going to be there? The a, and the power would be n. Okay, so everything like on the screen right now you've done already. Now, there are rules that we have between exponents that we can add and subtract and multiply them, whatever. So on one column, we're going to write the definition. On the next column, I'm going to give you some examples that show just that one property. And then we'll turn the page and like kind of put all the properties together. Nightmare. Nightmare. Not fun. So the first one is called the product of powers. So we have two exponential terms that have the same base.
And you multiply them together. Get my microphone closer.
So for example, if you look over here, you've got that x and the x, they have the same base. When you're multiplying those together, you can add the exponent. And I think you've seen this one before. So if I were to pick out keywords here, first thing is they have to have the same base. And if you're trying to multiply them together, then you're going to be adding the exponent. And here's the reason why you add. If I have x to the third, that's the same thing as saying x times x times x. If you have x squared, it would be x times x. Well, what is that? Isn't that x to the fifth?
Yeah, that's why you add the exponents. It's like you're expanding that exponential term.
So looking at the next one, 2 to the 4th times 2 to the 8th is the same thing as saying 2 to the 12th.
But 2 to the 12th is a number, right? You could plug it into your calculator. What do you get? Did somebody say it? So are y'all plugging it into your calculator now then? She says sweetly, reminding her class that this is a math class. If you don't have calculators, you could do that. 2 to the 12th is what?
4,096. Because what does that mean? 2 times 2 is 4, times 2 is 8, times 2 is 16, 32, 64, 128, and so on. It's just going up. So 4,096. Look at the next one. Now in this one I've got two different variables, right? You only add the exponent if it has the same base. So these have the same base, right? I kind of like to go alphabetical, so v to the 8th, y to the 7th, but that would be the same answer, y to the 7th, v to the 8th.
It's all about that base stuff. Okay, yeah, what?
There's a little caret symbol like that.
Do you see it? Thank you, by the way, for laughing. Appreciate that.
Okay, now we're going to do the quotient of powers. Quotient means divide, right? So this is going to start out very similar. When two exponential terms with the same base are divided.
You guys are aware that I have highlighters over there that you can borrow at any given time, right? Colored pencils. If you ever want to like highlight things in your notes, just grab one. If you think you'll use it every day, just grab it and keep it. I don't care. You can steal my highlighters as long as you don't lose it. Don't take one every day. That would make me really sad. But if you feel like a highlighter is useful, grab one.
Now what do you think the rule is here? I'm multiplying, right, with the same base. I added the power. What do you think the rule is when I divide?
We're going to subtract, yeah. Okay, so on this one, they have to have the same base. When we are dividing them, we will subtract those powers. So it will look something like this. This is why, if I had x to the fifth, it's x2, 3, 4, 5 divided by x squared. So this is the reason why you subtract them. What happens when you have something on top and something on bottom? They're going to cancel, right? So really what's happening here is I've got an x on top and an x on bottom canceling. So it's like we are subtracting them away. X to the third. That's how many x's are left. What about the next one? 5 to the 14th divided by 5 to the 9th would be 5 to the 5th. Now, could you figure out what 5 to the 5th is? Like 6, I don't know what it is. Somebody tell me. Okay, apparently 3,125. Yeah. And again, plugging that into your calculator, 5 caret 5. Or 5 times. You can do it that way too. Okay, let's keep going. The zero property is probably the easiest. Any number raised to the 0 power is, try it on the calculator, so plug something in. Don't do 0 to 0 because that confuses the calculator, but anything else. 5 to 0, 1 to 0, 27 to 0, 989 to 0. Try it, what is it? The same number, what is it? 1. Oh, did you try it? Because I might have gone fast. Just kidding, back up, try it. I just like stole that from you, that moment. What is it? Okay, now you have to be really careful. Look at the difference. Well, first of all, y to the 0 is 1. Look at the difference between the middle and the last example here. On this middle example, everything's being raised to the 0 power, which means my answer is 1. But looking at the next one, does the 5 have the 0 power with it? No, only the r. So this right here is 1, right? So I could rewrite it as 5 times 1, which is 5. So be really careful. The parentheses on this assignment mean a lot. Sometimes, yeah. We'll practice more with that in just a minute. The negative exponent, let's skip that one for a second because I think the negative exponent is probably the hardest. Let's jump to power of a power, like this. When you have a power being raised to a power, let me show you, like, looking at this x squared to the third. That means x squared times x squared times x squared, right? If I use that very first rule that I gave you with the multiply and then the exponents, what would that be? X to the what? 6. So looking at that 2 and the 3, how could I get the 6? Yeah, you multiply. We're going to multiply those exponents. And the reason is, it's like, because isn't multiply and add very connected? Right? If I said 2 times 3, that means I've got 2 groups of 3. So multiply and add are very connected. Just try to multiply and add together. So this would be x to the 6. Look at the next one though, that power 2. There's 2 things inside that first cube, 3 raised to the power 2. Okay? So looking at this one right here, it's kind of like you're distributing. So this power goes to the 2, but it also goes to the 4th, or x to the 4th. So if I were to rewrite that, it would be 2 to the 2nd times x to the 8th The biggest mistake here is forgetting to raise that 2 to the power. Can I simplify this though? 2 squared is 4, x to the 8. Is that okay? One last thing. If you have anything inside parentheses that can simplify first, so the 2 and the 3, I can multiply those together and get 6, and then xy. Is that all right? Raised to the 4th. So I'm going to simplify inside parentheses first if I can, and then I'll deal with any sort of exponents. Now each of these have a power of 1, so let's multiply that with 4. So I've got 6 to the 4th, x to the 4th, y to the 4th. And then anything you can do there, 6 to the 4th is? Figured if I left off that first digit, somebody would correct me. I just couldn't hear it. No, it's okay. I just don't hear very well sometimes, so I sometimes just like really have to like watch you talk so I can connect what you're saying with like your mouth movement. And let's jump back up to the one we haven't done yet. The negative power property, the negative exponent. This is not a very technical math term. Now when I say numbers being flipped, what math term does that involve? Starts with R. Reciprocal, yeah. So here's what happens. Anything that has a negative exponent means I'm going to take the term and I'm going to flip it. So if it's on the top, I'm going to move it to the bottom. So because that t is negative, the power is negative, it goes from the top to the bottom, and when you move it to the bottom, the power becomes positive. Have you done that before? I don't know. Yeah? Maybe? Maybe. Now what's left on top? If everything moves from the top to the bottom, the top will be a 1. Good. Now I know the next one has parentheses on it, but the parentheses really aren't doing anything. If the parentheses were right here, it would. If the parentheses, don't write that in. If the parentheses are right here, that means the 5 and the r have that negative exponent. But as it's written right now, which of those two numbers, the 5 or the r, has the negative exponent? Just the r, right? So I need to ignore the 5 completely first. The r goes from the bottom to the top. Try not to zone out on me. And when it moves to the top, the exponent becomes positive, right? Now what do we do with the 5? Remove it. Because it doesn't have that negative exponent, you can go about it. Okay, so that's right? It's not a lot of fun. That's right. Doesn't have to be. So now I've got a bunch of examples for us to try to make sure we really know how to do this before we move on. Okay. Let's take maybe 10 minutes to get through as many examples as we can. And then at that time, I'm going to set you loose on your homework for a minute, and then we'll come back together. We'll kind of go back and forth. But I don't want to take any longer than 10 minutes on this, otherwise mutiny or something will happen. Okay, part A, what do we do? Look at the numbers first, the 2 and the 2. 2 and 2 can combine to make a 4. Good. And then the n and the n, 4 n to the what? Second. Good. Because that has the power 1, that has the power 1, so we would add those two powers together. Part B, when we have a power raised to a power, what do we do with those exponents? I can multiply them. So r squared cubed would be r to the what? Unfortunately, these are just things you're going to have to memorize. Hopefully with a lot of practice. With a lot of practice that will help. Okay, part C. Any ideas? Or try it, see what you think. So, okay, why? Yeah. We square the 5 and we square the x. Try the next one. So I'll give you. When there's two kinds of people, you can just sit there and wait for it to happen and then just copy it down, right? But when you do that, your brain isn't trying to make that connection yet. You'll understand it better if you do it first, and then if you make mistakes, you erase it, that's fine. But if you try it, you're just going to do better. Okay, this one's going to be 2 what? 2n to the 5th. Why? The 2 can't combine into anything. It just is that front, and then n to the 1st, n to the 4th. We'll add those together to make a 5th. Okay, try the next one. So my plan from here on out is to give you 30 seconds to just try it. I'll do math and pencil and read it. Okay, part E. What's the number in front? What's the coefficient? That's what it's called. 6 what? X to the 5th. Very good. Multiply the 2 and the 3, and then you can add those powers. Okay, 30 seconds. Try part F. Unless you already have. When you're done and you have an answer, just check improvements in the next year. Let's make sure we have the same thing. Good question. In order for it to be considered simplified, you can't have any negative exponents. So if you do have a negative exponent, you're going to have to do something with it. So part F. Does the 3 combine with anything? No. And then what do we do when I've got a power and a power next to each other? Good. So we're going to add those exponents. So 3k to the negative 1 would be like the first step. Now, my k is negative. That has a negative power, right? So what does the negative power do? It moves it to the bottom, right? So you can think of it as a reciprocal. You can think of it as just like moving from the top to the bottom. So final answer here. Now, which one's moving? Is the k moving or the 3? Yeah, the 3 is already on top. The k moves to the bottom. Okay. Part G, try it. Having done that one, try G. Okay, part G. What's the number in front? So 6, we have to multiply those because they're just numbers. And then n to what? The first step. N to the negative, this is the 1. The negative 2 when I add them together. Is that alright? Now that n is negative, the power, right? So which one's moving? Is the 6 moving or is the n moving? The n goes down. When it goes down, it makes it positive. The 2 is with it because that's the power connected to it. The 6, is it up or down? Yeah, it stays up. Cool, try part H. Power raised to a power. Compare part H with part C. What happens between the 5 and the 25? What happens between the x and the x squared? Coming back here. I have to cube the 2, I have to cube the b to the 4th. So what's my first number out here? 2 cubed is 8. B to the power raised to a power, what do you do? Multiply the b to the 12. Questions? Oh, let's do one more. Part I. You actually see this a lot on your homework. There's only like this one on the notes. What's my answer for part I? Yeah, it doesn't matter what's going on inside. 1. I think there's a test question. It looks like this. Hold on. It's got all sorts of like garbage going on up in here, and there's like some ugly thing you have to simplify, and then it says 0. So the answer is 1. Like, it's a really weird question. Most people try to like simplify all this crap in here, and it takes a really long time, and then they just so sorry. It's really been kind of funny. Okay, so yeah, this one. Any questions so far? Yeah, that's that one. Any other questions? All right, part J. We have a power raised to a power. There's 2 ways to look at part J. I think I'm going to walk through this one and then let you try part K. I'm going to raise each part of that term to the -3. So I'll have 2 to the -3 times p to the what? Most ones. You have a power raised to a power, right? So p to the 6. Now if I make that into a fraction because I have a negative exponent, will the p be on top or will the 2 be on top? Or both, what is it? Does the 2 have a negative exponent? Yeah, so it goes down, right? If p has a positive exponent, it stays up. Now can I rewrite anything there? Yeah, final answer, p to the 6 over 8. Good. Try part K then. Everybody gets the 3. 3 cubed times r to the what? -3. One of them is negative, so it's going to happen to be in a fraction when we're done. Will the r be on top or will the r be on bottom? Good. And when it goes to the bottom, what happens to the negative? It goes away because the negative is what's making it go to the bottom. So once it moves, the negative's gone. What about on top? 3 cubed is 27. Who got that? Good. So the next one. And the next one. L and M. Yes. using the quotient rule, right? I don't really care what the name is, but what happens when you have some on top and some on bottom? You subtract them, yep. Looking at part M, you have two things here that are happening. First, simplify the, if you ever look at something like this, simplify the top, simplify the bottom if you can, and then combine the top and the bottom together. So looking at the top, you have x negative 2, negative 2. What will that be? X to the what? Good. Over, bottom doesn't simplify, 3x. So that's our first step. Second step, you have some on top and some on bottom. So what do you do there? Subtract the 4 and the 1 would mean there's now 3 on top, because one of them would cancel. Is that okay? And then what's left on bottom? Okay, cool. Try number or part N. Okay, one more time. So this is one long multiplication question, right? Just so I put a little multiply sign in between all of these. Assuming that that step is that first one, right? Okay, looking at part N. What's your leading, like that coefficient, that first number? What is it? 2 and the 4 make a 8. I like to go numerical order or alphabetical order, so I put the M next. Does it combine with anything? And the 4th, and then N to the what? N to the 7th. If you had those flipped, is it wrong? No, because multiply can happen in any order. What about part O? Try it. We'll do O and then we'll do R. And then we'll be done for a minute. We'll do O, we'll do R, and then we'll jump back to do one homework question together, and then you'll work on your homework for a little bit. Combine those numbers, what do you get? Combining the 4 with the 2, 8, x's, x to the 4th, very good. Y's, y to the negative 1. So now which of those three pieces of the term have the negative with it? The y. So the 8x to the 4th stays on top. The y bumps to the bottom. The negative goes away because it moved to the bottom, it's gone. Who got that? Good. Good, good, good. Okay, one more. Looking at this one. Combine the top first. 2 what? X to the 5th. Now on bottom, everything has that -1, right? You could, excuse me, look at this two ways. You could distribute that -1. Or could you take that entire chunk and move it to the top? This whole thing, because the negative is going to go up top. So 2x squared. Which means there is nothing now on the bottom. 1, but who cares about the 1, right? Nothing's left on bottom. Now, if I'm looking at this, final answer would be what? 2 times 2 is 4. X to the 7th. Okay, let's look at your homework really quick. You don't have your homework yet, I know, but almost everything we've done so far on the... Do you like that one right there? What's the answer to this one? Yeah, okay. Everything we've done so far has dealt with a lot of x's and variables. On your homework, there's a significant amount that have numbers instead of variables. The base is a 2. If I were doing something like number 3, here's how I would do it. I first want to simplify the top, and I'm not going to take care of the 2 times 2 because it's the base of the power of the exponent. So I'm not going to take care of any of the 2's until the very end. The first thing I notice is that 2 to the 0 is 1. I'm going to cross it out and just put 1. I'll leave this up here. Then, what I have left is right here, which in this case would be 2 to the negative what? 4. Is that right? So I make that a 1, and then I have 2 to the negative 4 over 2 to the 4. Yes? Not necessarily. You can do inside the first piece. Then, I notice because of the negative, I can take this and do what with it? Move it to the bottom. So on bottom, you would have 2 to the 4th, 2 to the 4th. What would you have on top? A 1. Now they have the same base, so what could I do with the exponent? 2 to the 8th. And at this point, could you figure out what 2 to the 8th was? Yes. Now notice I didn't do anything with these 2's or those 2's until the very end because that's the base. Think of it like an x. This would be 1 over... There you go. Memorize my. Okay. So let me give you your homework. Now your homework, I started to create the empathy. And 2 out of the 4 assignments, I didn't feel creating homework so hard. I don't want to give you so much that it's busy work, because that's really annoying to do math forever and just to get it done. But I also want to make sure I give you good problems so that you're ready for a test. It didn't feel like the homework that was originally planned would help you for the test. So we created the first homework assignment, and then I got to day 3's homework assignment, and again, day 3 is not good enough to prepare you for the test, so I just created that one for you. 16 out of your 4-day packet, 2 out of the 4 days you had to do the same. So we'll do it fast tomorrow, and we'll all work off the first day, and then we'll work off the third day. Okay, we need probably, yeah, 40 minutes there. Work on this, you only have about 7 minutes. See how many you get done in 7 minutes. And then just go on in. Yes. Ignore that and multiply it. It's the same as everything else. Technically, there could be a multiply in everything. So the first one would be x, y squared. Did anybody transfer out? I'm wondering. Okay. We just have an empty desk right here, and I don't know why I would have put an empty desk right there. I'm really glad that you're here today, though, and you didn't know I'm still recording. Pause. It's funny. And pause. Okay, here we go. Now, if you looked over to the back page of your homework, you may have noticed that the exponent has the fraction.
So before you say and multiply, if they have fractions, so you just have to remember how to do fractions, right? That's maybe a very painful part of your math memory, but let's remind ourselves how to add, subtract, multiply, and divide fractions. Okay, you all are actually going to do that stab. You finished, it's fine. Let's move on. Okay, if I want to add and subtract fractions, they have to have a what? A common denominator. When did you learn this? Do you remember? I never did, which is why I hate it. And I told you how much of a brat I was when I was a third grader, right? No? My mom was not a math person. She was a very nice person, which is why I'm nice. But she's not a math person. My dad's the math person in my family, which is not why. Anyway, did both of them, and then now you have me. But she did not do math, did not like fractions at all. I was okay with fractions because I've always been fine with fractions. But I would go and ask her how to do my fraction homework just because I knew she couldn't. And then I'd have to hear her say, I don't know how to do that. Brat, go away. And I'd laugh and I'd go do my homework. It's rude. Remember, I was 10. Like 10-year-olds are rude. Fine. Okay, common denominator. Look at this first one. What would the common denominator be? 9. So this 5/9 stays the same, right? What do you do with the 3? Triple it. So that means I have to triple this one, make it a 6. We are going to kind of fly through these because although they're not pleasant, it is something I expect you already know how to do. Okay, looking at the next one, common denominator between the 4 and the 5 would be a 20. Now what do I do to the 4 to get a 20? 5. What do I do to the 1? Times it by 5. So I get a 5 on top. Now I have to adjust the 3/5, right? Multiply the top and the bottom by 4. You get a 12. And then what right there between those two? 5 minus 12 is negative 7 over 20. Slight story. Okay, cool. How do you multiply fractions? Do you need a common denominator when you multiply? No, you just multiply straight across. So in this case, 2 times 2, 4. Over. Done. Now you could, it's called cross-canceling, you could cancel before you multiply. That's going to make any sort of reducing easier. So looking at this one, you got the 6 and the 3, right? They're both divisible by 3. So could I simplify that first? And if I do, that's going to make the multiply faster. So 1 times 2 is 2 over 7. What about divide? There is a special rule with divide. We talked about it last unit when we were trying to deal with those sine, cosine things. Yes? Close. Multiply the reciprocal. You freeze the first one. Change the divide to a multiply, and then flip. Freeze, change, flip. So you freeze the first one, change it to a multiply, flip the second. So final answer for this would be 4 over 3. How do I flip a 14 though? Put a 1 under it, so you freeze the first one, change to a multiply, and then flip. Is there some cross-canceling that can happen here? Yeah, take care of that first, it will make the multiplying easier. So 7 and 14, what goes into both of those numbers? 7, divide by 7 you get 1, divide by 7 you get 2, and then multiply straight across. What will you get? 1 over 8. So why do we care about that? Well, sometimes your exponent won't be whole numbers. Sometimes they will be fractions. And you need to know how to deal with that. Now, we don't have a lot of time. I'm going to spend 3 minutes on this, get as many of them done as we can, and then we're moving into the very last section. We spent a little bit too much time doing problems on the first section. So looking at, let's jump around part B. When you have a power raised to a power, what do? You times them, even when the powers are fractions. So this would be r to the 2 over 2, is that okay? Which is r to the first, but in math we don't put ones unless we have to. So this final answer would be,
After Olivia's pirate story the other day, R is my new favorite variable to use. Just remember that moment. Funny. Okay, part C. Now technically that's a multiply, right? So what do you do to the exponents when the bases are being multiplied? You add them. Now, conveniently here, they already have a common denominator, right? So this would be x to the what? 2/3. Please don't say 2/6. Breaks my little heart. You only multiply when it's a power raised to a power. You add them to thirds. So, part D, try it. D. So this, the exponent on the first n is just a 1, but we're going to write that 1 in a very strategic way. What would I call it? Instead of 1 over 1, I want to call it 3 over 3. Why? Yeah, so I get that common denominator. So I call it 3 over 3. Now I can add those fractions together. Final answer will be n to the what? How do you add fractions? 7/3. Good. Is that okay? So the same rules apply. Now you just have to think of a different way to add and subtract your fractions. Some of your calculators will add and subtract fractions for you. You just have to plug it in and it's done. That's convenient. I think yours is yours. Yeah. So that's all you have to do is plug them in. You don't actually have to find a common denominator, depending on your calculator. What about this one? You have a power raised to a power. What do? You multiply. Good. So this will be v to the 2/6. Is that okay? But you can reduce that 2/6. V to the 1/3. What about part F? Ignore the 3 for a minute. Okay, cut it off for a second. Look at just the k's. Because the k's have the same base. What do you do to the exponent? You have to add the exponents. But in order to add those, what do you have to have? A common denominator. So instead of saying 2 here, I want the denominator to be 2. Instead of 2 over 1, it's going to be what over what? Is that okay? 4 over 2. So I've got the negative 1/2 from here, the 2 from here, and we're going to add those together. What do we get? K to the, I feel like I've lost you. You just have to know how to add fractions. The rules are exactly the same. But if I'm looking at the 1/2 and the 2, that's how you add those together, is right here. What? Okay, sorry, I guess I skipped a step that I shouldn't have. Oh, hold on. Wait. So plus 2 over 1? Okay. I'd rather change it to 4 over 2, is that okay? Because now they have a common denominator. And then you get the 3/2. Let's do one more before we move on. Try part G. When you're done with part G, if you're waiting for me in the line, you're welcome to work on your homework. You have your notes there before you work on your homework. If we get more in. Okay, part G, what happens to the 2's? You have a 2 on top and a 2 on bottom. You cancel them out. Now, what's the rule when you have a power over a power? What do you do with those exponents? The quotient rule.
You subtract them. So it's going to be x to the 3/2 minus, what's down here? 1. Is that okay? But in order to subtract that 1, we have to rename it. Instead of saying 1, what am I going to call it? 2 over 2? Conveniently calling it 2 over 2 so that it has the common denominator. Now can I subtract them? Is there anything else I can do here? The rule is no negative exponents. So that's all I can do. Now the question is, what does x to the 1/2 mean? So now we are going to transition down to this. Actually, x to the 1/2 is the same thing as saying the square root of x. Let me show you how to change them from fractional exponents to radicals. That's our last step, and then we're done. So yes, this section's harder, but the reason it's harder is because you don't know what these add to easily, or what those multiply to easily. These fractions aren't part of your memory base, like numbers, or like whole numbers are. Okay, one last thing and then we're done. So if I have a fractional exponent, that is the same thing as writing it as a square root. The numerator of the exponent is inside the radical. And it is the power, or it's the exponent. The numerator of the fraction, the numerator, what am I, what's that? I think I messed up twice now. I don't think that's supposed to be exponent, I think it's supposed to be fraction. The numerator of the fraction is inside the radical, it's the exponent. Notice that the m right here and the m right here, those are the same number. And honestly, that's something you just have to memorize. Hopefully with a lot of practice you'll get used to it, but if you don't, before you take any sort of test or quiz, it needs to be memorized. The denominator is the index. Now the index determines what kind of radical it is. It's the number that goes right here. Will that number ever be a 1? No. N is never a 1. It will never be a 0. It will never be anything negative. It has to be 2 or greater. Now looking at this one, we have 2 examples. One example goes from radical form to exponent form. So the base here is x, and now you need a fraction. The power is the what? The numerator is the power. They go together. The denominator is the index. They go together. So the numerator, 8, is the power. The denominator, 5, is the index. Not too bad. But look at part B. See how in part B you have square root, the 6 and the x is in parentheses? That's the base. That's the whole base. It has a fractional power. Where does the 2 go? Top or bottom? 2 goes top or bottom? Good. The power is the numerator. The index, in this case of 3, is the denominator. The parentheses mattered. If you don't have the parentheses, it's a different answer. You have to have them. What about part C? The base is what? X. What's the numerator? Good. What's the denominator? But it's never 1. So what is it? Ooh, if I just said the square root of 100, what number actually goes right here? It's a 2, right? We're looking for groups of 2. So the denominator is a 2. Just in math, if we don't have to write something, we don't. Maybe mathematicians are just really lazy people. I don't know. But if you don't have to write something, they don't write it. So you just need to know if there's nothing there, it's going to be a 2. Guaranteed test question. It'll be on there. Now, does that simplify? X to the what? The 3rd. Okay, now let's go backwards. Let's take the exponent and write it in radical form. So looking at part A, D is on the inside. You could write this 2 different ways really quick. Notice how the 8 was on the outside here, but was inside the radical there. It doesn't matter. It can either be inside the radical or outside. Now, the 1 is the one the index, or is it the power? Elise? Where? Right here? 6 divided by 2 is 3. The 1 is the power. We're going to put it right here, but do you have to have it? No. And what about the 2? That's the index. It goes here, but do you have to have it? No. So that's your answer. If you put the 1 in, or if you put the 2 in, it will not be marked wrong. It's just not needed. It's not necessary. What about, now compare part B with part C. Notice how this one has the parentheses, this one does not. On part B, what's the base? 3n. Where does the 7 go? The 7 goes inside, the 4 goes index. You should never put a v with a square root, that was really funny. Okay, looking at this one though, what's the base on part C? The base is just x. The 2 does not have the power with it, so ignore the 2 for just a minute. Inside the radical is x. What's the power with the x? 4. And what's the index? 3. So what happens to the 2? It just stays outside with it. So pay attention. When I have a grouping symbol like this, I'm grouping the entire term inside the radical or outside the radical. If there isn't a parentheses, the answer looks different, so be careful with that one. I didn't leave you much time. Before you leave today, I do want one thing from you. This is your exit slip today. So hand it to me before you leave. You'll be fast and easy, though. You're fine. All you have to do is write mine. I'm not going to count my questions because that's coming up. I want your name on it. I need you to answer one question for me. Okay, so it might take a few more words than just a letter. Put your name on it. I want to know what your goal grade is this quarter and what you plan on doing to get it. So, for example, if your goal grade is just to get a C minus, because maybe you didn't get a C minus last quarter, you need to tell me I'm going to come in after school and need help when I need it. If your goal grade is to get an A, but you got a B this quarter, then obviously you need to do something more this quarter, right? Different content, so who knows, but so I want to know your goal grade. Now, if you got an A last quarter, then that's fine. I'm going to keep doing what I've been doing. It's working for me, so I can okay answer here. So I want to know your goal grade and what you plan on doing to get there. And then you'll have to do it. Brilliant, right? Now hold on to these, because I want to know, like I thought tonight this on, right in front of me, like if your own goal is to get a B, and that's fine, I don't want to keep pushing your A, your goal is a B, right? That's fine. If I know that her goal is an A, then I'm going to keep pushing until I have that A, right? And my goal is to step it back. Maybe, I'm going to take a test, and I'm going to take a square, so I'm going to get a green on it, or whatever.
Calling students to the front office, Samantha Stewart, Macy Berry, Megan Jones to the main office.
Unless you're loud when you come in, I usually forget to not party. Thank you. I'm gonna get really jealous of you because your B3 teacher in Apple already too. This is special between you and me.
Haha, yes. Ooh, that smells good. Fantastic. I don't even know if my notes are downloaded yet. So I probably should figure that out. All right. Nope, gotta get that done. No, it was on my probably recommended something, I don't know. This is brilliant. Why did I not think of that sooner? Thank you so much. Secondary math. That's not what I wanted. I'm still recording. Yeah, thank you.